Hi guys, welcome to this set of videos. And these videos are going to follow along with the notes that come out of your book from Chapter 8, Section 4. Now what we've been doing in Chapter 8 is we've been looking at rational expressions. And we started in Sections 1 and Sections 2 at looking how you can simplify rational expressions by factoring. And then once you finish factoring, finding the restricted domain values that give you division by zero. Once we went through sort of the algebra that's involved with rational expressions and simplifying them, we then moved on to adding, subtracting, multiplying, and dividing rational expressions and really kind of looking at the parallels between what you guys did in middle school with fractions and kind of how that parallels to what we were doing here in Chapter 8 with rational expressions. Then in Section 3, just the last section, we began to take a brief look at graphing rational functions. And what we saw was that anytime you graph a rational function, they have a very sort of distinct look. And we took a look at the reciprocal function, the parent function for these rational functions and what it looks like. And then we talked a little bit about how you go about kind of piecing together the graph. And a couple of things we talked about were finding the h value, which is in the denominator, and how a value that gives you 0 in the denominator will show up on the graph as a vertical asymptote, right? And so how we restrict the domain and how we can write the domain and the range and interval notation based on those restrictions. We also then took a look at the value of k and how that shifts the horizontal asymptote, and again all that discussion about asymptotes and how they're lines that you can approach and not cross. And so everything that we did in the last section with Section 3 as far as graphing rational functions, we're going to rely on all of that here in this section as well, but we're going to do slightly more complicated rational functions here in this section, just kind of build those graphing skills we've already started to develop. So before we jump into this, let me give you a couple of objectives or learning targets to kind of help us focus as we make our way through this set of notes. And these are the things we're going to ask you to do when being able to graph rational functions. You'll need to be able to graph a rational function with vertical and horizontal asymptotes, and we talked about how we will go about finding those vertical and horizontal asymptotes, and we'll give you a few more tips and tricks here in this section for finding those vertical and horizontal asymptotes. And then we'll go a little bit further. We'll also begin to take a look at graphing rational functions that have oblique. Oblique is just a fancy way of saying a slanted asymptote. So it's an asymptote that is neither vertical nor horizontal, but slanted. It's oblique. And we'll also look for point discontinuity, which is really just a fancy way of saying there's a hole in the graph. And so we'll take a look at all of that stuff as well. And as we get to the end of this set of notes, we'll graph a couple rational functions where you could have all of this stuff. A vertical asymptote, a slanted asymptote, and a hole in the graph, all in the exact same rational function. Tons of fun. I love this section. Graphing these rational functions is really kind of like putting together a puzzle. You'll have to do a lot of little algebra tricks to figure out the pieces. And as you begin to put those pieces together on the coordinate plane, you'll kind of see the graph of the function take shape. So I really like doing these for that reason. It's kind of mystery, and you got to kind of figure out the mystery, and it's a lot of fun. We'll go ahead and jump right into this here by actually taking this chart right here, which does a really good job of summarizing vertical and horizontal asymptotes for you, but I've put all this information kind of the way I've written it on the next page. So let me head over to this page, and here's where I'll take some time to go over first vertical and horizontal asymptotes. Let's start with vertical because they're the easier ones. So when it comes to the vertical asymptotes, remember the vertical asymptote is a line, a vertical line that the graph of the function will approach but never touch. And the way that we find the vertical asymptotes is by setting the denominator equal to 0 and solving for x. So when you have these rational functions, just like we did in the previous section and even the sections before that, you'll take your denominator, set it equal to 0, and solve for x. Any values you get will be undefined. All right, we'll have to restrict our domain, and in some cases, those values will show up as vertical asymptotes on the graph. And we'll see examples of that as we jump into these problems. But now I want to talk about horizontal asymptotes, because what happened in the previous section was the horizontal asymptote was given to us by the value of k. Okay? But the functions we're going to look at today are a little bit more complicated than what we did in section 3. And so we're going to need another way of figuring out the horizontal asymptote if I can't just tell the value of k by looking at the function. In some cases, that value of k will be disguised in the function, and you won't be able to just look at it and go, oh, there's my k. We'll need to do a little bit of algebra, some work to kind of figure out what's going on with the horizontal asymptote, and that's what I described for you right here. So the way these are going to work for horizontal asymptotes, get my highlighter, horizontal asymptotes. A couple of, just a couple quick things for you here. First of all, the function will only have one horizontal asymptote. At most, that is the most it can have, one horizontal asymptote. We'll actually see a couple of examples where that is not true for vertical asymptotes. It's possible to have more than one vertical asymptote, but not so for horizontal. If there's a horizontal asymptote, there will only be one of them. And there doesn't even have to be a horizontal asymptote. It is entirely possible for the graph to not have any horizontal asymptotes. So when it comes to horizontal asymptotes, guys, you're going to need to remember 3 rules. 3 rules for graphing rational functions and the horizontal asymptote, and let's go through them together right now. Here's what I've done. I have given you a rational function, right? I have a function f of x. I have a of x, which is going to represent a polynomial in the numerator, and I have b of x, which will represent a polynomial in the denominator, right? Both of these guys are polynomials. All right, so this is a polynomial, and this guy is a polynomial. Now, when it comes to these 3 rules, how do you know which rule is the one that applies to your rational function? Well, this goes back to chapter 5 here in Algebra 2, where we talked about polynomials and finding the degree of a polynomial. Let me quickly remind you how you determine the degree. You take your polynomial, you write it in descending order of power, right? So the largest power first, the next biggest power after that, the next biggest, and descending order of powers. The degree of the polynomial is equal to the largest power, all right? The degree of the polynomial is equal to the largest power. So just for example, if we had f of x, actually let's call it p of x because it's a polynomial, is, I don't know, let's say 4x plus x squared minus 2, right? This is my polynomial. Well, the first thing you need to do is put the polynomial in descending order. All right, well, p of x is going to be equal to 2 is my biggest power, 1 is the next biggest, that is 0, so it'll be x squared plus 4x minus 2, and what is the degree of the polynomial? It's equal to the largest power, so this would be a degree 2 polynomial, or a second degree polynomial. All right, so that's how you determine the degree. So you'll look at the polynomial on the top, figure out the degree. If you have to rearrange the terms, fine, put them in descending order and get the degree. And then you'll look at the degree of the bottom. If you have to rearrange the terms, fine, put them in descending order, figure out the degree of the bottom. Then the 3 rules, rule 1, rule 2, and rule 3, are based on the degree. So let's go through them. Rule number 1, if the degree of a of x, that's the top, is greater than the degree of b of x. So here's what you take a look at. Polynomial on the top is, let's say degree 2. Polynomial on the bottom is degree 1. Well, 2 is greater than 1. That means you have rule number 1, and rule number 1 tells you that particular rational function has no horizontal asymptote. There isn't one, and that's okay. not all rational functions will have a horizontal asymptote. We'll talk about this more later when we start doing some problems, but it turns out no horizontal asymptote means that you have an oblique asymptote. Actually, it will be a slanted asymptote. QUE. Now, when we get started doing some of these problems, if we get rule 1, we'll just ignore that for the moment as we kind of get used to doing these problems. But later on in this set of notes, we'll look at rational functions where it'll be rule number 1, the degree of the top will be greater than the degree of the bottom, and I'll show you how we then go about finding that oblique asymptote. So rule number 1, no horizontal asymptote, and the reason there's no horizontal asymptote is because there's actually a slanted asymptote. And we'll look at how to find that. But then the other rules. Rule number 2, if the degree of a of x is less than b of x. So you take a look at this, the degree in the top is less than the degree in the bottom. Let's say the degree of the top is 1, the degree of the bottom is 2. Well, 1 is less than 2, and so you have rule number 2, if the degree of a of x is less than the degree of b of x, and here's what it tells you. The horizontal asymptote is y equals 0. That's the x-axis. So you have a horizontal asymptote that is the x-axis, and we'll look at examples of that. And then finally, rule number 3, you guessed it, there's only one option left. If the degree of a of x, the degree of the polynomial on the top, is equal to the degree of b of x, the polynomial on the bottom, then you have rule number 3, and here's the way it works. The horizontal asymptote will be the horizontal line y equals, right? It's a horizontal line, so all horizontal lines have the function y equals. Y equals, it'll be the leading coefficient of a. So you'll find that leading coefficient of the polynomial on the top divided by the leading coefficient of the polynomial in the bottom. And I know that sounds like a mouthful, and you're like, how the heck am I ever going to figure that out? It's not that difficult. I'll show you examples here in just a second. I got a couple of example problems for us to work through to practice figuring out these rules. Vertical asymptotes, that's easy. Set the denominator equal to 0 and solve. But these 3 rules for horizontal asymptotes, it's kind of new and we need to get a little practice. So head on over to the next page in the notes. We'll try a couple of these together. I'll meet you guys there.